what I want to do today is continue and finish off section 2, 3. There's two methods up here, but we've covered them. Remember, when you evaluate, you plug a number in, and if it's 42, that's the limit. And we factored and cancelled. Right, we've seen that technique. We did see the conjugate method. So I just want to do one more of those, like it's an overlap. And then the last part is we're going to look at, well, how do you find limits if they don't really fall into the first three categories? And I've decided just to call them using algebra to simplify. So there are going to be some limits that aren't, you know, just factor and cancel, right? They're ready to be factored and you factor and cancel them. Or like this, they're square roots, so you know it's a conjugate. And the other possibility is that if you plug a number in, you get the dreaded 0 over 0, the indeterminate form. So in this question here, oops. You do this guy, take away this guy, because these are the square roots, and you do the conjugate, which if I'd planned ahead, I would have made more room. That guy, add that guy. And that guy, add that guy. So essentially, it's a special version of one. Are you comfortable that if you know where the square root is, are you comfortable about what the conjugate looks like? Because it's really the same two guys, isn't it? But with an add.
Yeah,
now,
we're just doing the square, completing the square method, right? And it's like minus square root plus square root, so we get rid of the square roots.
Essentially. And so when you do the difference of squares, all you need to do is take the first guy times himself. So this guy times himself gets you t add 4. And take away, that's important, this guy times himself, which gives you t squared take away 16. And then you typically don't do anything to the other end. So in this case, the bottom. There is no point in you foiling that out or distributing that. It would just look messy and it wouldn't help. Are we comfortable with first guy squared, take away second guy squared as a shortcut? Otherwise, do some foiling with some really ugly terms. But when you're finished, that's what you're going to end up with. Now, you notice I put a subtraction and did that so that when I expand this, it looks like that. Being, oops, that's just a T. Being a, here we go. Being the last one of the conjugate method, I decided to give you a really, really stinky one to finish with. I've always figured out if you can do the worst ones, then everything else is going to be easy. I have a negative t squared, a plus t, and a 24. Let me check this. 9, 25, take away 16 is 9. That's good. Okay. T plus 4 is good. That's good. T squared is good. T is good. 4, take away a negative. Yep, that's good. Something's not right.
How'd you get the 20 in the second to last?
I have no idea.
Okay.
And now I know that I'm happy because that's what was wrong. There's something that wasn't right and you figured out. I think I know what I did. I added some reason 4 and 16 together when I shouldn't have done it until here. I added it and I left the other 4 alone. So it should be just 4 add 16 and 4 add 16 gets me that 20. Are we good? But thanks for catching that. Now, this has to factor. There's just no way around it. It has to factor. but it's got negative t squared in it. And that's not good. Definitely not good for factoring. But we can fix it. While I'm writing this down, maybe you could think about how I could fix it. What do you think I might do to just make it a little bit easier for factoring?
Factor out a negative. A -1.
Okay.
From the
That's good. Are you comfortable about, technically speaking, I shouldn't have put a 1 there, but I'm doing it for emphasis. Right, if you factor out a -1, do you see that becomes positive, that becomes negative, and that becomes negative. And that means I can now factor it. Okay, t squared minus t minus 20. Would you agree that's a pretty standard no frills factor situation? We're looking for two numbers that multiply to give me -20, and 5 and 4 are the two guys, and 5's going to go there and 4's going to go there. Agreed? You happy about this factors? Is that? Got nods? I like nods. Those two cancel. It's a good sign. So it's now going to be the limit as t tends to 5 of negative t add 4 over the square root of t add 4 add the square root of t squared, take away 16. And at this point, I can now plug in 5. So on the top, I get 5 add 4 is 9, so -9 on the top. 5 in here gets you the square root of 9, which is 3. 5 in here gets you 25, take away 16 is 9, and the square 9 is 3. So I get -9 over 6. Bingo. -3/2. Now, don't expect anything as ugly as that one as a typical question, right? That's like the end of the line one where everything you could do to make it ugly has been put into it, right? You see it's got 2 square roots instead of 1. That's pretty rare. When you've done all your work, the guy on the top that should factor nicely has a problem with it. In this case, it's a negative. I think last time, didn't we do a 2 minus x that had to be turned into an x minus 2 and sucked out a negative so you could cancel it, right? So that's like the grown-up version of that same problem, right? Where you had to suck out a -1 to allow you to do the factoring so you could cancel. But at the end of the day, it came out quite nice, didn't it? Now, this is not a replacement for what I've just done. But I'll bring this down a little bit. If you remember, the original question was the limit as x tends to 5 of this really ugly fraction. And we believe that the answer is 3/2, right? That's 1.5. So what I'm going to do here is I'm going to go y equals, I'm going to clear this out. I'm going to do a bracket, the square root of t plus 4. So it's going to be the square root of x plus 4. Take away the square root again of, well, it's going to be x squared minus 16. Right, that's all of that done. Probably need another bracket. Yeah, and then divide by this fella. X take away 5. And then I'm going to go to table setup, and it's already set up the way I did, so I guess I didn't need that step. I'm now going to table set. Let's just clear that list out the way. Can I do that? Okay. Well, forget those numbers. That's from past experience. So we're interested in the limit tends to 5. So how about 4 point lots of 9s? Ah, do you see the answer? Negative 1.5 at the top there. Let's be sure, 5 point lots of zeros. I know why I wanted this a 4. Can you see that it verifies what we found algebraically? We found that the limit was negative 1.5, and these two guys at the top undo that. And now I feel real comfortable. Now in WebAssign, you don't need to do this check, because won't WebAssign just have a nice green tick? You know, check, you got it right. But can you imagine you doing your tests where you don't get WebAssign to tell you if you're right or wrong? Isn't this a relatively quick way to check? Whatever dog that was, it agrees with what I just said, so that proves that I'm right. You heard the dog saying correct, didn't you? That's what I heard. Okay. Any questions about that process, or do you feel it had a kind of natural progression? Thumbs up, I like. Okay. Our last thing, using algebra. Right, this catch-all phrase, using algebra, doesn't really, it's not one method. It's really just, you got something that you want to find a limit of, and none of the other techniques work. So somehow or other, we've got to simplify it, right? Rearrange it, make it turn into something else that we can deal with. So I'm just looking at one right off the top of my head. So this is similar to question 14 in the homework. It's the limit as x tends to 5 of 1 over x times that guy over that guy. Of course, the first thing I would do would be just to evaluate. Well, can you trust me? It's 0 over 0. Right? And in my head, it takes seconds. So I know it's not going to work. So I got to figure out how to deal with this. I think the big problem is there's nothing to cancel that I can see, right? And typically you end up cancelling. Even the conjugate method, don't you eventually end up cancelling, right? There's a bit at the end where this guy in the top cancels out this guy in the bottom. Really, the guy that we need to get rid of is this x minus 5 in the bottom, because he's causing a 0 in the bottom, and that kind of screws up any possible answer. There's at least, and I'm saying at least because some of you are much cleverer than I am, there's at least 2 ways to fix this problem. Can anybody think of any strategy that they might use? Even if it's not right, what's your brain thinking?
Well, it's fractions, so using fraction busters by times by x minus 5 to get rid of the x minus 5, so it's just fractions.
Right, so if I'm picking up right, you want to deal with these fractions up here and make them nicer in some way, for want of a better word. Okay, that sounds like a good plan. I'm going to do a version of what you just said there. The other version is, couldn't you just take these 2 guys over here and combine them into a single fraction? Right, that would be another strategy. I'm going to do, because I like this technique, it's not the conjugate method, but it is similar. I'm going to multiply the top and bottom by a special version of 1. Would you agree 5x over 5x is 1? Right? If the guy in the top's the same thing as the guy in the bottom, you've just multiplied by 1. Now you might think, where on earth is that 5x coming from? Why is it not 10x or just 5 or x or anything else? This guy has to disappear. I don't want a fraction. So if I multiply this by x top and bottom, that would go away. But I don't want this fifth either. And so to make it disappear, right, stop being a fraction, I'm going to do a 5/5 on that. And that's essentially why I picked that. So let's see what happens algebraically. And the bottom's just going to be x minus 5. I'll stick it there now, times 5x. 1/x times 5x. 1/x multiplied by 5x gets you 5. Don't the x's essentially cancel? And the -1/5, if you multiply it by 5x, so I'm just doing this bit, and don't the 5's cancel, and you get -x. So what you end up with is that. Do you see that I've successfully got rid of the fractions? Similar kind of idea of what Robin's up to, right? I don't want a fraction. I got to figure a way. This is my way of doing it. Not the only way to do it, but this is my way of doing it. Now, look really carefully because this has happened before. Can I cancel those?
-1, right?
-1, right? So what we're now going to get is the limit as x tends to 5 of -1/5x. Oh, -1/5 times 5, -1/25. We're done. You see, what we did here is we used algebra, essentially, didn't we? To take a limit, which was that guy, that we really couldn't do anything with, right? We couldn't factor it. It's not a conjugate. You couldn't plug in the number 5. None of the usual techniques are going to help. And we figured out an algebraic way of essentially taking care of the fractions. And by taking care of them, we eventually got the cancel that we wanted, because you are going to have to do a cancel. Do you like that one? A little bit of algebra skill. Let's see if we can find, there's lots of them around. And they're not really the same. You got to treat each question. This is like, oops, this is similar to question 16. You got to treat each question on its own merits. Oh, sorry. That's a 0. I was scanning up and down and I picked up a number from a different question. So it's the limit. Oh, shooting space. Let's start again. So the limit is h tends to 0 of x plus h cubed. Take away x cubed all over h. There, that's the right question. There we go. Now, there's an added difficulty, isn't there? 2 variables here, x and h. So we haven't kind of had to deal with that before. It's not the major problem. If you plug 0 in here, doesn't x plus 0 get you x? So x cubed take away x cubed is 0 on the top, and h is 0 on the bottom. It's 0/0, right? So indeterminate form. Good luck trying to factor that in the form that it's in. Would you agree it's probably not going to factor? At least I can't see an obvious vector. So there's no square roots in it. So what does it mean? It means we're left with algebra. What do you think I'm going to have to do with the top? I'm looking at it and I think it ain't much help the way it's written. I got to figure out something else to write it like. It's kind of obvious. Maybe that's the problem. It's something you didn't even think would be helpful, but it is.
You have to FOIL it?
Yeah. You're saying it in a way like I don't want to, but yes, you have to FOIL it. That's it. Now, you're going to have to trust me on this one because I don't want to spend time doing it. But x plus h times x plus h times x plus h can be done. But you have to do it in 2 steps. You have to multiply one x plus h by another x plus h, get that answer, and then take that answer and multiply it by x plus h. So you're just going to trust me on this, that you get an x cubed, a 3x squared h, a 3x h squared, and an h cubed. Can you just trust me that that's what you get? Because trust me, right? I'm a mathematician, right? If I tell you it's true, it's true. But you can check it yourself later. So let's see what algebra has brought us. Well, actually, something nice happened. Can you see it?
X cubed cancels and you can factor an h.
Agreed. Cancels. Which leaves us, and is correct as well, with this expression, which in turn, when I pull out h as a common factor, looking good? Can't we cancel? There's the cancelling thing, right? The h's. And now we're left with this weird looking thing. I agree, that's kind of weird looking. We haven't seen anything quite like that in these questions. What do you think I'm going to do? Because we're one line off the answer.
Factor it, right?
Not going to do anything clever.
Just put the 0 in?
Yeah, I'm just going to plug 0 in for h. Now, what's that going to get me? Well, it's going to get me 3x squared, because it doesn't have anything to do with h's. Won't this be 3x times nothing, which means it's 0? And won't this be 0 squared, which means it's 0? So it means that our answer to this limit is 3x squared. What you might not know, and this is jumping the gun a little bit, but if you take the function x cubed and you find the slope of the tangent line at any given point, it's the value of 3x squared. So we've actually done our first derivative without telling you. I know it's a while back. What are we trying to do this for? The whole purpose of what's going on here is so that we can eventually put it all together as a package and find slopes of tangent lines, right? Find derivatives. And this is what's happening here. So it's kind of cool, I think. Let's see if we've got anybody else that we've still got some algebra with. Okay, plenty of time. Do one last example of the algebra, guys. And I think this has pretty much covered it. This is a bit like question 8. And it's a limit as h tends to 0 of h take away 9 squared take away 81 over h. Okay, you got 2 minutes, go for it. You do it first. No pressure, you got 1 minute. Okay, let's go for it. You don't need to tell me the details. If you want to, you can, of course. But what will we do to the top row, the top part of this fraction?
Multiply it out like the last problem.
And got that? Agreed. What do we do next?
Add and subtract.
What do we do next?
Gonna
Okay, so essentially these cancel out. Great.
You wanted to factor out an H there too.
Yeah, I probably should have and saved some time. Too late now, so I'll just write it there, right? Which means that when these cancel out, do you feel comfortable now about how to find limits using algebra techniques?
Yeah, yes.
I tried to sell.
I do have a question about one when you get a minute.
Yes.
I just had a question. I have this ugly one that I did, and I finally got it to be e minus 5, the square root of x e plus 4 over e minus 1. And is that okay to put the 0 in for that x root and get rid of that sucker? Does that just, or is that an illegal thing to do?
You have to rewind a little bit. You were doing, is this just one that you created yourself, or is this one that was from the homework?
It was one in the WebAssign.
Okay, so what did it start life off as? Could you tell me the original question?
It started life as e to the 1 over x minus 4 over e to the 1 over x plus 1. So e to the
Like
e to the 1 over x.
Oh, okay.
Yeah, e to the 1 over x minus 4 on top.
Like that?
Well, kind of. It was minus 4 on top. And then
Okay,
that whole thing is divided by e to the 1 over x plus 1.
And the limit as x tends to
0.
0.
So I got it down.
And this is in,
Yeah.
right, and this question is, I'm trying to think where this question is. Is this in this section, or is this in the section that's still to happen?
2.6.
I don't know. I was just doing the homework and I was doing them all, and then I came to this one. So I didn't really pay attention if it's in this section or not. I don't know. Does it go advanced? Like one set of homework goes beyond this section?
I can't find it in the ones that I can see in front of me.
Okay.
So I'm scanning right now in case I missed it, because it is possible that I missed it.
Yeah.
I think this question may have came from the numerical ones, where you did it through a table of values. I think what you would be doing in this question would be, if we call all of this here f of x, then you'd be doing a 0.001, 0.0001 kind of thing.
Okay.
And then maybe a negative 0.001 and a negative 0.001, that kind of thing.
Yeah.
And the table of values would give you an estimate. Algebraically, there's not a heck of a lot I could do with that would help.
Yeah.
So
it was difficult.
I'm not sure I could do any factoring on it. It would be.
Okay.
So are we good with this? Right. Are we good with this? Because I'm going to leave it if we don't have any more problems.
How do you do the problem that she just asked about? Like
you do it numerically.
Okay.
You can't do it algebraically.
Okay, got you. Can you do it?
There are some.
You couldn't plug it in on your calculator, could you?
Yeah, I could plug it in and then just do tables of values until I got really close to 0, and hopefully it tended to be a number.
Okay.
I'm a little. I guess I could think about doing some algebra on it, but the only algebra I could think about doing on it would be to multiply top and bottom by e to the negative 1 over x. And I think this question has 2 answers. I think if you come in from the right-hand side, the answer is not the same number as if you come in from the left-hand side. It's kind of broken. So that doesn't, I'm not going to quote me on this because I haven't done the numbers. I just got a gut feeling that it might be that it doesn't have an overall limit. It just has a left and a right that are different numbers. Right. That's what my gut feeling is.
Okay.
So yeah, there are some situations that you meet in the earlier questions where algebra is not going to work. It's just not a viable technique, you know. And it's a bit unfortunate that algebra can't be used in every situation in the universe. But I guess sometimes engineer technique of plugging in numbers and getting an approximation, sometimes that just has to be, right? That's the only way you can do anything. Now, hopefully right now you are looking at the homework from that section, right? So I'm just going to scan through the questions and we'll talk about the general techniques, right? And remember we did these ones where basically you just find the value of this and the value of that and you combine them. So evaluate, right? Question 2 is evaluate. Question 3 is evaluate. What technique will I use for question 4?
Factor.
You're saying it, but I can't hear it, Kelsey. What do you do for question 4?
Algebra. You'd have to factor it out and then cancel.
No? Right. So so this is a factor and cancel situation, right? Question 5 is a factor and cancel. Agreed? Question 5 is a factor and cancel. Does that look good? Take out a common factor of x on the top and you've got a trinomial on the bottom. Would you agree that 6 and 7 are factor and cancels? Isn't that the one that we did earlier, or that one there? They're both essentially the same. Isn't that the algebra technique, right? You just FOIL it out and see what you get. What's question 10? What method is question 10?
Conjugate.
Conjugate. Tell us why. You're right. Why is it conjugate? What was a clue?
Because it's got the square root in the denominator.
Right. So won't it be 5 plus square root of x, top and bottom? Conjugate method. Would you agree 11, 12, 13 are conjugate methods, right? You see what they've got. The reason I'm kind of just going through these is that you've got 4 techniques, but if you don't know which one's the right one to use, aren't you going to have a bit of a problem? So there are clues in what it looks like matches with a technique, right? So if I see a square root, I'm thinking conjugate, right? That's pretty much guaranteed. Now, when you look at 14, do you see that is what we did today was an algebra question? And didn't we basically multiply top and bottom by 5x? Remember we did that one. What's 15 and 16?
Algebra problems.
Are they?
Aren't
Look again.
Conjugate?
Yeah. What makes them conjugate and not algebra?
Because they have the square roots.
Because they have the square root. Think square roots. So you see a square root, it's going to be conjugate, right? Just take it for granted. It's going to be conjugate. Well, God, I should say always. If it was x plus the square root of 7, it's probably not a conjugate, right? But apart from those very silly situations, if you see a square root, it's going to be a conjugate. And isn't 17 algebra? In fact, that was one of the ones we did today. Are we comfortable? I don't want to move on if we're not, but I think we are. I'm getting a lot of nods. I guess you'll find out when you do the homework. So we are now going to move to a very small section. It has 3 questions in it. excuse me. And it's a pain in the butt. I'll just tell you right off the bat. The section is going to be called, I'm trying to get the numbers here, 2.4. And I guess it should be called the formal definition of a limit. In a lot of textbooks, it's called the delta I can't spell today. The delta epsilon method. So if you want to go and look up some more of these, feel free to. This thing called the formal definition of a limit, the delta epsilon method, is the lawyer-esque version of why we could do everything that we've already done in the previous sections. Right? Why can you take 5 and plug it into an expression, and if you get the answer, it's a limit, right? We said it is, but what's the proof that that actually is going to be true every single time in the universe, right? If you go into it deeply, why does factor and cancel work? Why does conjugate method? You tell me they work and they give me an answer, and I've checked on tables and they work, but you know, that's not a proof, you know. Somebody might invent a really weird function with square roots in it that the conjugate method says the answer is 4, but the real limit is 2, you know. Just to say that couldn't happen. Well, it can't happen because the formal definition of a limit essentially took the whole process and broke it apart. So although this is a pain in the butt, there are there's 2 good things coming out of this. Number 1, there's only 3 questions, and I'm going to do all 3 questions with you. So we're essentially going to do the homework as a class, probably tomorrow. Right? That's the first one. And the second thing is, I'm not going to ask you a test question or a final exam question on them. Right? So I'm putting it here, and we're going to cover it so that I've ticked the box saying, if some of the calc professor said, did you do the delta epsilon? And I will say, yes, we covered it, and we didn't do it that deeply. And they will probably say, you're right, neither do I, but we did cover it, so we feel good about it. So let's start the ball rolling by looking at what does this thing look like? Well, let's pick a function, and we're not picking anything weird and wonderful. There we go. And this function is y equals f of x. Now, do you notice that this function doesn't have vertical asymptotes in it? Probably isn't a rational function. It's just like x cubed plus 1, right? It's just a normal, boring function. And we're only going to look at the formal definition of a limit for this situation. So I'm going to imagine that we're interested in the limit of the function as x tends to a. Now, if I go up with a little dot here and I go here, would you agree that the value of the function at a is called f of a? Right. There's nothing that weird going on here, right? It's basically proving that evaluate works. So that's essentially what we're going to do. So how do we prove that? Well, this is the definition. And I'm writing it down in English, and then I'll show you what it looks like a little bit more algebraically in a second. For any value of epsilon that you wish. So you go to your little guy up here, and you say, I'm telling you that the limit as x tends to a of f of x equals f of a. And somebody says to me, okay then, can you prove to me that you can get within 0.00001 of f of a? Can you find an interval in the x's where every single number in that range, every x in that range, will give me an answer that's within a tolerance of epsilon? So can you imagine what epsilon might look like? This would be f of a plus epsilon, right? And this guy would be f of a take away epsilon. So you go along here, and you get a guy down here, and you go along here, and you get a guy here. So what the thing says, for any value of epsilon that you wish, so you can give me epsilon to be 0.4 zillion zeros and a 2, right? That's your choice. You can find a delta, which has to be greater than 0. I guess I should tell you who delta is. That's him. Such that for all values of x in the range so for any value of epsilon that you wish, you can find a delta that's greater than 0 such that for all values of x in the range x between here and here, that f of x will be in the range f of a plus epsilon, f of a take away epsilon. Doesn't that look like some lawyer got involved in mathematics? I mean, it's a bit like the party of the first party is the party of the second party, and so on and so forth. It's quite lawyer-esque looking. Now, if you want to see it in the way that it is typically written in math books, it would look something like this. That funny upside down A represents for all epsilon greater than 0. That backward E is there exists a delta greater than 0 such that, although such that is very often 2 dots, this shows you how mathematics turns into a language of its own, like hieroglyphics, such that the absolute value of f of x take away f of a will be less than delta for all x's that belong to x minus a. Oh, sorry, that's epsilon up there. And that's delta. So what I just wrote there is this. And you're probably still none the wiser of what has he done? He's wrote down a whole load of sentences and it hasn't really came to much yet. Well, let's go back to this fella here. I'm saying that the limit as you tend towards A is this guy called f of A. I'm picking an epsilon that you gave me that does this. This comes along and down gives me a range. What I'm saying here is that can't we find these two endpoints? And one of these two endpoints is going to be smaller than the other. And I'm going to call that guy delta. So can you imagine that I pick any value of x from here to here? Because it looks to me like that side is a little bit smaller on this one. If you pick anybody in that range, won't all the answers fall inside this tolerance? And so the logic is, if you can make this as small as you like, and you can still reduce this to make it work, then the argument in logic is that this limit becomes that guy in the middle, f of a. And I think